Hi, welcome to this tutorial. We'll introduce you to another statistic known as analysis of variance, abbreviated as ANOVA. ANOVA is a powerful statistical tool that allows researchers to compare means of different groups. It was introduced by R.A. Fisher in the 1920s and later published in his book titled Statistical Method for Research Workers. The origin of ANOVA begins when R.A. Fisher was working in the Rothamsted Institute, also known as, formerly known as Rothamsted Experimental Station. And this institution was later renamed as Institute of Arable Crop Research because the activities done there were purely agricultural practices trying to improve crop production and food security. And so while Fisher was working on some crops, testing treatment on certain crops, he had 3 or more groups, and at that time there were z-tests that he can use to test for significant difference between the treatments on the crops. But however, instead Fisher thought that there are some certain problems that may arise while doing pairwise comparison, that is 2 by 2. For instance, if he had 3 treatments, he will have to compare A and B, A and C, and B and C, which may actually increase the overall error rates in his research. So as such, being a statistician and a polymath, R.A. Fisher decided to develop a particular method that he can use to analyze the effect of the treatments across the group simultaneously without using t-test or z-test. He went back to his office and started developing an equation to be able to compare the 3 groups at the same time. So, and that led to the origin of ANOVA in his research. And today, ANOVA has widely been used in many researches, and even not only in agriculture, in education, in medicine, in businesses, and so on. So ANOVA, according to R.A. Fisher, it is the ratio of the explained variance between the group and the unexplained variance within the group. So, and the purpose of ANOVA is to test difference in the means of a continuous variable, especially across 3 or more groups defined by a single categorical independent variable. So you can use ANOVA to test for significant difference between exam scores, because exam scores are continuous data, especially if they are beyond 2 groups. So you can compare exam scores across different teaching methods. You can also compare efficacy of drugs across multiple dosage using analysis of variance. In a situation where there are significant difference among the group, then a post hoc test is necessary. And the post hoc test will help you. It's like a follow-up test that will help to check for which of the group that led to the significant difference to occur. There are certain advantages using ANOVA over t-test, because in some researches I've seen where a researcher is having let's say 3 groups, independent groups, and instead of using ANOVA to test for significant difference and proceed for a post hoc test, rather be using either t-test or z-test. Actually, t-tests are mostly used when the sample size is small, because it was developed by Gosset to test for significant difference for small sample. One of the reasons is that why ANOVA is very advantageous is that it reduces that pairwise into a single omnibus test instead of multiple comparison. With this single omnibus test, the error rate is reduced as against when doing pairwise. Let's take for instance using t-test where having 3 groups. You have to pair the group 2 by 2, A and B, A and C, and B and C. Now if we follow this structure, it means that the overall error rate will be 1 minus the difference between 1 and 0.05 raised to the power of 3. And when you compute this, then you will have 14.3%. That is 0.1426, something like that percent. So this will not go well with your test of hypothesis of 0.05, because the overall error rate has been increased significantly from 0.05 or from 5% to 14.3%. So using ANOVA, it will reduce this overall error rate. And secondly, the total variability among the group will reduce. For instance, if you have 3 groups while you are using t-test, you might have 3 variants. However, or if you have 4, for instance, you may have up to like 5 variants while using t-test. But using ANOVA, even if the group are up to 10, then the total variability will be reduced into 2 components: between the sample variance and within the sample variance. And another significance of ANOVA is that the post hoc adjustment adjusts the significance threshold by lowering the alpha for each pairwise test. And because of its strong emphasis on the assumptions, you using ANOVA make sure that these assumptions are met. And one of these assumptions is that there must be independence among the group. The group must up to be at least 3, minimum of 3, and there will be independence among the group. Then secondly, the data should be continuous, either measured using interval or ratio scale, such as exam scores, time at which certain cells occurred. You can compute using a variance. So another thing is that the data must be normally distributed or approximately normally distributed, because there are no real world data that is actually normally distributed. There may be a little bit of skewness, but when computed they will be approximately normally distributed. And then there must be homogeneity of variance, homoscedasticity of variance. The variance may be should be at least almost equal across the group. And although sometimes the variance may differ, and when it differs, then you have to look at the Welsh ANOVA. So any violation of these assumptions means that one has to look for an alternative. An alternative of the non-parametric test for ANOVA is Kruskal-Wallis H test. Now, ANOVA can be used as a one-way ANOVA or a two-way ANOVA. When you have a single independent variable you have to test for significant difference among the group, then you can use a one-way ANOVA. A two-way ANOVA is when you have 2 independent variables and you want to test the 2 independent variables at the same time. One of the independent variable is the main variable. The other is just like a second factor. Like in this table here, you can see the independent group. We have the treatment 1, 2, and 3. But this treatment 1, 2, and 3 can also be further factored into male and female. Assuming these treatments here are teaching methods, different teaching methods. So in this class, it means they are male and they are female. The same thing in treatment 2 and treatment 3. So the researcher may assume that there may be an effect of this gender, so you check for the main effect and interaction effect in terms of the two-way ANOVA. For the one-way ANOVA, you only check for main effect. That's just the difference among the 3 group if the treatments are either equally effective or not equally effective. One aspect of this one-way ANOVA is that the design is so very simple and easy to interpret. It's just to test if there is significant difference across the group or not. If there is, then you proceed for a post hoc test to check which of the group made the difference possible. And if there is none, then you stop there and report that there is no significant difference across the group. But for that of two-way ANOVA, it is a little bit complex, because while checking for main effect, you have to also check for interaction effects. So for the main effect is that the effect of the treatment on the respondent or on your product, and see what was the outcome. But for the interaction effect, you are trying to look at how the treatment affect the population depending on the second factor. In the case of this lesson here, we're looking at gender. You can also look at other examples, like for instance when you are studying crop yield by fertilizer type and irrigation method. So here is a kind of typical two-way ANOVA, where you look at different types of fertilizer on crop yield, then varying also the irrigation methods. And second, another example here for a two-way ANOVA is analyzing sales based on advertising medium and time of the day. Advertising medium can be maybe national dailies, or it might be social medias, and even in the social media, which of the social media? Is it Twitter, or is it Facebook, or is it WhatsApp, or whatever? Then at what particular time of the day does those sales occur effectively? So this is a kind of a typical example of a two-way ANOVA. So in conclusion, we can say ANOVA can be one-way or a two-way ANOVA, and their foundational tools for comparing group means a group should be at least above 2, minimum of 3. So while one-way ANOVA addresses single factor questions, two-way ANOVA expands insights by evaluating multiple factors and as well as their interaction. Their interaction is dependency, so the effect of treatment depending on another factor. So a proper application of ANOVA has to adhere to the assumptions and thoughtful interpretation of results. So in a situation where one of or two of the assumptions are met, then and others are not met, then an alternative to ANOVA should be considered for the analysis. Thank you very much for listening. Have a wonderful day. Do appreciate us, because it takes time for us to put in this video, and the only way you can appreciate our video is by subscribing to our YouTube channel or any other of our channel where you get our videos. Subscribe to our channel, also turn on the notification bell so that you get notified once we upload a new video. Give us a little comment on how you see our video.